Welcome to the Local and Anonymous Class Challenge. First, you need to create a record named Employee that contains first name, last name, and hire date. You'll be using this record as a domain class, which you can pretend you don't have the luxury of changing. Next, set up a list of employees with various names and hire dates in the main method. Then, set up a new method that takes this list of employees as a parameter. Create a local class to wrap this class, pass employee to the constructor, and include a field for this, and add some calculated fields such as full name and years worked. Create a list of employees using your local class. Create an anonymous class to sort your local class employees by full name or years worked. Print the sorted list. Hint: here is another review of a date function which should help you with calculating years worked. I'll be covering dates and time thoroughly in an upcoming section of the course. Okay, that's your challenge. Pause the video and give that a try. Remember that a local class is a class declaration in a method block, and you can create many instances of it. So that's why your employee wrapper class should be set up as a local class. An anonymous class is a single instance of an unnamed class, and you've seen an example of a comparator already, and you'll be doing that here. When you're done and want to see my solution, come back and we'll walk through it together. Okay, so how'd you do? Were you able to build that? Let's go through this together. It will hopefully cement your understanding of the differences between local and anonymous classes and get you ready for the fun stuff to come, Lambda expressions. I've created a project called Local Class Challenge. I'll start by creating a record in dev.lpa.domain called employee. At the moment it has no fields, but I need to add 3. I've put this in a different package, and I want to remind you the challenge was not to touch or amend this record, but to use a local class to manipulate data and add functionality. I now want to go to the main class and set up some employees. I'll set up 5 manually here. And now I'll add them to a new list. Next, I'll set up a new method that will contain both the local and anonymous classes. I'm passing a list of employee, and I also have one other parameter, which is sort field. If this field indicates to sort by name, I'll sort by name, otherwise by years worked. Next, I want to get the current year, using the simple date function I gave you as a hint. I'll set up my local class now. In this code, I'm calling the class myEmployee. I'm not extending the employee class because it's a record, and you can't use a record in the extends class, but this isn't a problem for what we want to do here. I've got a contained employee field, which will just reference the original employee instance. I'll have 2 other fields, years worked, an integer, and full name, a string. I'll add a constructor. In addition to assigning contained employee to my contained employee field, I'll derive the years worked next. In this code, I'm splitting my string by the /, and then the third split should be the year. I run that through integer.parseInt to get the year as an integer, and subtracting it from the current year. For the full name, I'll use string.join because I want to keep reminding you of the many options on string. Lastly, I want a toString method for my local class. I'll replace the call to super.toString with the following. This just returns the full name and the years worked by the employee. And that's the local class, so it's not too complicated. I want a list of these now, so I'll loop through the list of employees and create a new list of them. Now that I have a list of my employees, I want to sort them in 2 different ways, based on the method argument sortField. I'll start with setting up the comparator. Unlike the local class, which I used to create many instances of, I really only need 1 instance of this class for a very finite purpose to change the way these employees are sorted. This doesn't compile yet because it implements the comparator interface, so I have to implement the compare method. Let me generate that code. What's fun about a class generated in a method is that we can use method arguments or local variables to determine the behavior that will happen in the anonymous class. I'm going to use my sortField method argument to determine how to compare the employees. Because sort field never changes values, it's effectively final, and I can use it in my anonymous class code. If sort field has the value name, the sort will use the full name field on the local class to sort by. Otherwise, it will sort by the years worked field on the local class. Don't worry if you didn't code it this way. I just wanted to give you a little something extra to think about, how local variables and method arguments can influence what is happening in these temporary classes. Now that I have a comparator, I can sort my list and I'll follow that up with an enhanced for loop to print each employee instance on a separate line. I just need to invoke this method from the main method. Let's run the code and see what happens. I get my employees printed out by their full name. Daffy Duck is first and Minnie Mouse is last. I'll try this with a year sort. So in the main method, I'll add a separator line and then invoke that method again with year, but I could really put anything there as long as it wasn't name. I'll run that so we can check the result. I get the list printed again, this time sorted by the year, so Goofy Dog is first, having only been employed for 3 years, and Mickey Mouse is last at 23 years. Okay, so this challenge allowed you to create both a local class and an anonymous class. I hope you had a little fun with that. That's the end of this section. In the next section, I'll be talking about Lambda expressions, and don't get discouraged if you feel like you haven't quite grasped everything about nested classes and types. In truth, these are features that are nice to know about, but may not be in your daily toolbox. They do lead to a deeper understanding of Lambda expressions, and these are becoming increasingly important as Java continues to release new features. Let's dive into them. I'll see you in the next section.